Have you ever really thought about what's inside that little black square that powers, well, pretty much everything? Your phone, your car, your computer. It's all run by these tiny marvels. Today, we're going to demystify the whole thing. We're going on a journey from a single grain of sand to the absolute heart of our digital world. Yep, we're going to build a computer chip, step by step. So let's start with a wild idea. I want you to picture a city. Not just any city, a massive, sprawling metropolis with billions of residents, where every single one has a critical job to do. Now, imagine building that entire city on a piece of land smaller than your pinky nail. Sounds totally impossible, right? Like something out of a sci-fi movie? Well, it's not. It's exactly what's happening inside every electronic device you own. The official technical name for this little wonder is an integrated circuit, or an IC. You probably just call it a computer chip, a processor, maybe the brains of your phone. But what it really is, it's an entire universe of electronic circuits, all perfectly, meticulously built on one tiny, flat piece of silicon. And the scale we're talking about here is just, it's honestly hard to wrap your head around. We're not talking about a few thousand components or even a few million. We are talking about billions. Billions of microscopic switches, what we call transistors, packed together, all working in perfect harmony inside our little silicon city. It's just incredible. So where in the world does this kind of microscopic construction happen? It all goes down in a place called a fab, which is short for a fabrication facility. But look, this is no ordinary factory. It's a clean room, an environment that is thousands of times cleaner than a hospital operating room. Seriously, to a computer chip, a single speck of dust is like a giant city-crushing boulder. It has to be perfect. All right, let's get building. Every city needs a solid foundation, and our silicon city is no different. So our first major job is to prepare the perfect plot of land, the silicon wafer, and get it prepped and ready for all the amazing structures we're about to build. And it all begins with this, the wafer. It's this perfectly circular, flat, mirror-smooth disk made of almost 100% pure silicon. So why silicon? Well, it's a fantastic semiconductor, which just means we can control exactly how it conducts electricity. Plus, it's stable, and it's literally as common as sand. This thing right here is the pristine canvas for our microscopic masterpiece. Okay, next up, we have to prep that canvas with a protective coating. We use a process called oxidation to grow this incredibly thin, flawless layer of silicon dioxide, which is basically just ultra-pure glass, right on top of the wafer. This layer is absolutely crucial. It acts as an insulator, making sure the electrical grid we're about to build doesn't short circuit. With our foundation ready to go, it is time to bring in the architects. We are moving on to what is, without a doubt, the single most important and most expensive part of this entire process. It's called photolithography. This is where we lay down the master plan for our entire city. Now, photolithography sounds super complicated, but the core idea is actually pretty easy to grasp. The best way to think of it is like high-tech photography. We are literally using light to print an insanely complex blueprint directly onto our silicon canvas. No ink, just light. So how does it work? First, you coat the whole wafer in a special light-sensitive chemical called a photoresist. Then you place a mask, which is like a super intricate stencil of your circuit, right over the wafer. After that, you blast it with powerful ultraviolet light. The light only passes through the clear parts of the mask. Finally, you wash the wafer, and all the exposed photoresist dissolves, leaving the perfect pattern for our city streets and buildings etched onto the surface. All right, our blueprint is down. It's perfect. Now it's time for the construction crews to get to work. We're going to build the actual structures of our city, all those billions of transistors, by repeating a cycle of 3 key techniques: doping, etching, and deposition. First tool out of the box is doping. This is where we intentionally introduce tiny impurities into the silicon, firing specific atoms into very precise locations. Why do this? It changes the silicon's electrical properties right where we want it to, creating these special little zones that become the all-important on and off switches for every single transistor. Next up, etching. So if photolithography was like drawing the blueprint, you can think of etching as the process of actually carving and sculpting that blueprint into a 3D reality. We are selectively removing material to create the physical shapes and trenches that will become our transistors. Now, there are a couple ways to do this. There's wet etching, which uses liquid chemicals to dissolve stuff away.
It works, but it's not super precise. For the really fine, detailed work, you need dry etching. This uses an ionized gas called a plasma to basically blast away material with incredible precision, almost one atom at a time. It's this level of control that lets us build smaller and more powerful chips.
The last step in our little construction loop is deposition, and it's exactly what it sounds like. If etching is about removing material, deposition is all about adding new material. We lay down ultra-thin films of different stuff, insulators, metals, you name it, building our city up, layer by microscopic layer. And get this whole cycle of printing, etching, and depositing can be repeated hundreds of times for just one chip. Okay, check it out. We now have billions of transistors, the individual residents of our silicon city. That's amazing! But a city full of residents is useless without infrastructure, right? You need roads, power lines, a communication network. It's time to wire this whole thing up. This step is called metallization. We create this incredibly dense, multi-layered network of microscopic copper wires to connect all those transistors together. This is the electrical grid that lets the signals fly, allowing the chip to make billions of calculations every single second. A modern chip can have more than a dozen layers of these wires, all stacked up like some crazy futuristic freeway interchange. So now that we've seen the whole process, we can use some industry speak. The entire construction project is really broken down into two main phases. First, there's the front end of line, or FEOL. That's all about building the transistors, the devices themselves, right on the silicon. Then you have the back end of line, or BEOL. That's when you build that massive, intricate network of metal wires that connects everything. We've done it. Our city is built, the lights are on, the whole thing is buzzing with potential. But before we can ship it out to the world, we have to run a final and very, very rigorous inspection. Quality control is everything. So the final stage kicks off with testing. Every single chip on that wafer gets put through its paces. Any chip that doesn't meet the absolute strictest performance standards gets marked and is later discarded. Only the perfect ones survive. Those survivors are then carefully sliced out of the wafer and sent to packaging. That's where they get put into that little black casing that protects them and gives them the metal pins they need to connect to the outside world. And all of that brings us to maybe the single most important word in the entire chip industry: yield. Yield is simply the percentage of working perfect chips you get from each wafer. A high yield is the holy grail for a fab. Even a tiny 1% improvement in yield can mean millions and millions of dollars. It's the final report card for this entire multi-billion-dollar construction project. I know, that was a ton of information. But look, if you only remember one thing from all of this, let it be this super simple trick. Print, build, connect, package. That's the whole thing in a nutshell. You print the blueprint, you build the structures, you connect the grid, and you package it up for the world. Simple as that. Let's do a real quick rapid-fire review of those key terms. The wafer? That's our foundation. The mask? That's the blueprint. Doping? That creates the on-off switches. Etching carves everything out. Metallization is the wiring. And yield? That's the final score, our success rate. Got it? Good. And there you have it. From a tiny grain of sand, we have built a buzzing, brilliant metropolis that powers our entire modern world. Seriously, every time you send a text, stream a movie, or ask a smart speaker for the weather, you are tapping into the awesome power of one of these incredible silicon cities. It really just leaves you wondering, if we can build entire worlds on the head of a pin, what on earth are we going to build next?